Why are virtual photons crucial for understanding electromagnetism? Imagine invisible messengers bouncing back and forth between charged particles, carrying the force that makes magnets stick and electric currents flow. That's where virtual photons come into play. They are not real particles like the light we see, but are temporary disturbances in the electromagnetic field. These disturbances are exchanged between particles like electrons and protons, and this exchange explains how they push or pull each other. In classical physics, we think of electric and magnetic fields as continuous forces spread out in space. But in quantum physics, these fields are made up of tiny particles called photons. Real photons are what we see as light, but virtual photons are different. They exist only for a very short time and do not travel freely through space. Instead, they act as the messengers that transfer energy and momentum between charged particles. When two electrons repel each other or a proton attracts an electron, they do so by exchanging virtual photons. This exchange creates the electromagnetic force we observe in circuits, antennas, and electronic devices. It's like a game of catch where the virtual photon is the ball being thrown back and forth. This process is fundamental because it explains the forces at a microscopic level, which classical physics cannot fully describe. From an electrical engineering point of view, virtual photons help us understand how electric and magnetic fields behave at very small scales. For example, the electric field around a charged wire can be thought of as a cloud of virtual photons. When charges move, they generate magnetic fields through the same virtual photon exchanges. This quantum view supports classical Maxwell's equations but adds a layer of understanding about what's happening at the particle level. Knowing about virtual photons is important for designing electronic components like capacitors and inductors. It also helps in understanding advanced technologies such as quantum computers and photonics devices. These devices relying on the principles of quantum mechanics, which include the idea of virtual particles mediating forces. In essence, virtual photons are the quantum carriers of the electromagnetic force. They connect classical fields with the tiny particles that make up the universe. This understanding bridges the gap between classical electromagnetism and quantum physics, giving us a clearer picture of how forces work at the smallest scales. Without virtual photons, our understanding of how electric and magnetic fields arise and interact would be incomplete. They are the invisible links that make the forces of electromagnetism possible at the fundamental level.